Okay, this is our 12.4 day 2 notes. We're going to keep looking at derivatives, finding the slope of our secant line, getting our slope generator, etc. But the examples that we're going to see today will involve cubing a binomial. So I just want to refresh your memory. This is something that we would have focused on a lot more if we were in school, but unfortunately we didn't have time. So I am just going to show you real quick how to cube a binomial. It's pretty straightforward, and there's a little pattern that goes along with it. So your first term is your first term in the binomial cubed. Then the second two terms always have a 3 as the coefficient. That will never change. Then the first term takes a decrease in the exponent. So if you'll look, a starts off being cubed, then it decreases, a is squared. Then it decreases again, a to the first, and then technically we have a to the 0 in the last term. So it is decreasing every time. The second term, so in this case, the b, it's doing the opposite. Its exponent is increasing every time. So technically, we have b to the 0 in the first term. Then we have b to the first power, and b to the second power, and b to the third power. All right, so if you can just remember that the first term decreases its exponent, the second term increases its exponent, and the middle two terms have a coefficient of 3. If you can remember that, then you're going to be in really good shape. And I'm going to show you what this looks like in our first example. So what we first have to focus on is getting the slope of our secant line, which is where we're using the difference quotient. So remember, that is f of x plus h minus f of x all over h. So I have 4 times the quantity x plus h cubed minus 3. Then I'm subtracting the quantity, which is 4x cubed minus 3. That's subtracting f of x. And this is all over h. So here's the part where we need to cube this binomial. Okay, so we have x plus h being cubed. So I have the 4 in front, and now I'm going to start cubing. So the first term is an x, so that gets the highest exponent, which is a 3. Plus, that x term starts to decrease its exponent, while the second term starts to increase its exponent. So now it has an exponent of 1. X decreases an exponent, h increases an exponent. H increases an exponent. And then the only thing we can't forget is that the coefficient for the two middle terms is 3. Okay, so that's all that looks like. And then we have minus 3 minus 4x cubed minus 3 all over h. All right, now I'm going to distribute that 4. So I have 4x cubed plus 12x squared h plus 12x h squared plus 4h to the third minus 3 minus 4x to the third, and actually that was my bad, that should be a plus 3 at the end there. All right, and this is all over h. Any terms without h's should cancel. 4x cubed, and a plus 3 and a minus 3. So everything left has an h, which means our next step is that we can factor out an h in the numerator. So I'm left with 12x squared plus 12x plus 4, there's one more h left on that one, and then plus 4h squared. All right, so now those h's cancel. So here is the slope of your secant line. All right, so there's the slope of your secant line. And the last thing, well, not the last thing, the next thing we need to do is find the derivative. So f prime of x is taking the limit as h approaches 0 of the slope of the secant line. So if we're using direct substitution, all of your h's are going to become 0. So that's going to go away and that's going to go away. So our derivative, or in other words, our slope generator is 12x squared. So now the point we are given is -1, -7. So I'm going to evaluate the derivative at -1. Which is going to be 12. So there's our slope and there's our point. So we have y plus 7 equals the slope of 12 times x plus 1.